Space, the final frontier, is not just a distant realm of planets and stars. It's a place that profoundly transforms the human body in ways we're only beginning to fully understand. For decades, astronauts have ventured beyond Earth's protective atmosphere, and in doing so, they've become unwitting test subjects for one of the greatest experiments in human physiology. So, what really happens to your body when you live and work in space? The answer is a fascinating story of adaptation, challenge, and resilience. Let's start with gravity, or rather, the lack of it. On Earth, gravity is a constant force that shapes every aspect of our bodies, from the way our blood flows to the way our bones support us. In the microgravity environment of space, everything changes. Within minutes of entering orbit, astronauts experience a sensation known as free fall. They aren't exactly weightless, but because their spacecraft is falling around Earth at the same rate they are, it feels as if gravity has disappeared. One of the first things astronauts notice is the feeling of lightness. Their arms and legs float effortlessly, and even the simplest tasks, like moving from one part of the station to another, become an exercise in physics. But this freedom comes at a cost. Without the constant pull of gravity, muscles begin to weaken, and bones start to lose minerals. In fact, astronauts can lose as much as 1 to 2% of their bone mass for every month spent in space. This bone loss is similar to what elderly people on Earth experience over years, and it's a significant challenge for long-term missions. To combat this, astronauts follow rigorous exercise routines, spending up to 2 hours a day on specially designed treadmills, stationary bikes, and resistance machines. These exercises simulate the effects of gravity and help slow down muscle and bone loss. But even with exercise, some loss is inevitable. Scientists are studying ways to prevent or reverse these changes, exploring everything from pharmaceuticals to dietary supplements. It's not just the skeletal system that's affected. The heart, which on Earth works constantly to pump blood upward against gravity, adapts to microgravity by becoming more spherical and slightly less efficient. Blood and other bodily fluids that normally pool in the legs are redistributed throughout the body, leading to what's known as moon face, puffy cheeks, and a stuffy nose. This fluid shift can also increase pressure inside the skull, causing vision problems in some astronauts that can persist even after they return to Earth. Your sense of balance also takes a hit. The inner ear contains tiny structures that help us maintain equilibrium, but without gravity, these structures don't function as they should. As a result, astronauts often experience space adaptation syndrome, a kind of motion sickness that can cause nausea, dizziness, and disorientation during the first days in orbit. Fortunately, most people adjust within a week as their brains learn to interpret new signals. The immune system, too, undergoes changes. Studies have shown that certain immune cells become less effective in space, and dormant viruses, like the herpes simplex virus, can reactivate. The reasons for these changes aren't fully understood, but stress, radiation, and altered sleep patterns likely play a role. To minimize risks, astronauts are carefully screened for infections before launch and monitored throughout their missions. Let's talk about sleep. In space, there's no sunrise or sunset, just 16 sunrises and sunsets every day as the International Space Station orbits Earth. This constant cycle can disrupt the body's circadian rhythm, making it hard to fall asleep and stay asleep. Astronauts often rely on sleep masks, earplugs, and carefully timed lighting to help regulate their internal clocks. But sleep deprivation remains a common problem. Then there's radiation. Earth's magnetic field shields us from much of the cosmic and solar radiation that fills space. But once you leave this protective bubble, exposure increases dramatically. High-energy particles can damage DNA and increase the risk of cancer, cataracts, and other health problems. Spacecraft are designed with shielding, and mission planners try to minimize time spent outside the protection of the planet's atmosphere. But radiation remains one of the biggest challenges for deep space travel. Space also affects the mind. Extended missions can lead to feelings of isolation, confinement, and homesickness. Astronauts miss their families, the feel of wind on their faces, and the simple pleasures of Earth, like fresh food and real showers. Teamwork, communication, and psychological support are crucial. NASA and other space agencies provide regular contact with loved ones, access to counselors, and a range of leisure activities to help astronauts cope. Interestingly, space can also bring unexpected benefits. Some astronauts report improvements in certain allergies and a temporary increase in height, up to 2 inches, as their spines decompress in microgravity. Others describe the overview effect, a profound sense of awe and connectedness that comes from seeing the Earth as a fragile blue marble floating in the void. When astronauts return to Earth, the process of readjustment begins. Gravity feels crushing at first, and it takes time for muscles, bones, and balance to return to normal. Some changes, like bone loss, can take months or even years to fully reverse. Others, like vision problems, may persist indefinitely. Every mission into space teaches us more about the remarkable adaptability of the human body. These lessons aren't just for future Mars explorers. They have real-world applications here on Earth. Research on bone loss and muscle wasting is helping scientists develop new treatments for osteoporosis and age-related muscle decline. Studies of the immune system in space are shedding light on autoimmune diseases and viral infections, and insights into sleep, stress, and teamwork are informing everything from hospital care to disaster response. In the end, the story of how space changes your body is a story of resilience. It's a testament to our ability to adapt, overcome, and thrive in even the most extreme environments. As we set our sights on longer journeys, back to the moon, onto Mars, and beyond, the lessons learned from the pioneers who have already ventured into the cosmos will be our guide. The human body may be challenged by space, but it is also endlessly adaptable. With the right knowledge, preparation, and determination, there's no telling how far we can go.